This is lesson 5.6, graphing inequalities in two variables. Here's the process that you will use when graphing inequalities in two variables. Number one, write the inequality in slope-intercept form. Y is either greater than or less than, greater than or equal to, less than or equal to, mx plus b. In slope-intercept form, let me just remind you, this is stuff that you should know, but I'll remind you anyway, where m represents the slope of your line, and b represents your y-intercept. Okay? Alright, so the next thing you will do is very much like drawing the actual line of the equation. You will graph the boundary, that's the line. If it's just a less than or greater than, then you draw a dashed line or a dotted line. If it's less than or equal to or greater than or equal to, then you will draw a solid line. Okay, you can compare that to the open circle on the number line and the closed circle on the number line. Okay. The line is called a boundary. It will separate your solution points from your non-solution points. Okay, then number 3, you will shade the appropriate side of the plane. If your inequality says that y is greater than or equal to, you shade above the boundary where the y values are greater. If your inequality states that y is less than or equal to, then you will shade below the boundary where the y values are lesser or are diminishing. Okay? All right. Let's start with number 1. Copy it down. Here is an inequality in two variables, and what we're going to do is we're going to graph this inequality. 3x minus y is less than or equal to 2. Our first step is to get this inequality in slope-intercept form. So let's isolate y. Let's start by subtracting 3x from both sides. So we have negative y is less than or equal to negative 3x plus 2. Then we'll divide both sides by negative 1. Let's recall, when we divide an inequality by a negative number, we have to flip the symbol. So y is now greater than or equal to positive 3x minus 2. Okay, so this inequality is our boundary. Okay, let's start there. Let's identify the slope of this inequality. It's going to be, the slope is 3 or 3 over 1, and the y-intercept is negative 2. Okay, so it gives me an idea of how to graph this. Okay, here we go. Let's start with drawing the x and y axis. Okay, and when we have inequalities, I am going to ask you to box it in. We're going to actually draw our inequality within a box. All right, so I'll start graphing. Let me just pick another color. I guess I'll do my line in red, my boundary. My y-intercept is at negative 2, so I'll plot that point right there. And my slope is positive 3, so I'm going to rise 3, run 1, go down 3 to the left 1, and I'll probably do that a couple more times just to get a good straight line. Okay. So I have to check the inequality. Because it's greater than or equal to, then what I'm going to do is I'm going to draw a solid boundary. A solid boundary. Okay? All right. So now if you notice, the square that I drew is divided into two parts by that red line, by that boundary. One part is going to be all of my solutions, which I'm going to shade. The other part is going to be all of my non-solutions, which I'm not going to shade. Okay, because the inequality reads y is greater, I go to my y-intercept and I'm going to highlight where y is greater than the y-intercept. And so everything on this side of my boundary is going to be shaded. All of this, every single point on this half plane are my solutions. And so I shade them in. Y is greater, is above, all the points above, where y is above the boundary. Okay, so that's number one. Okay, let's look at number two. Number two. Copy it down. X plus 5y is less than or equal to 10. All right, so my first step again is going to be to get this inequality into slope-intercept form. So let's work that out. Subtract x on both sides. 5y is less than or equal to negative x plus 10. Then I'm going to divide by 5 on both sides, and I have y less than or equal to negative 1/5 x plus 2. So here's what I know. The slope of this line is negative 1/5, and my y-intercept is 2. Okay, so let's go ahead and plan the graph. Whoops. Let's try that again. Okay. So here's my x-axis, here's my y-axis, and again, let me remind you that I do want you to draw a square around your coordinate plane. All right, so in red, I'm going to graph the boundary. The boundary is the line, okay? So I start at positive 2 on my y-axis. That would be, as you know, the y-intercept. And my slope is negative 1/5. So go down 1, positive 5, and do it again the other way. 5, and I'll try to make my line extend all the way through the square that I've drawn. Okay, so let's go ahead. Now let's look. This is a less than or equal to. If it includes the equal to, I will definitely have a solid line. Oops, oh, sorry about that. Okay, let's try this again. Solid line through my points. Okay, now as you look at the square that I've drawn, this red boundary divides the plane into two half planes. The coordinate plane is divided by that red boundary. So we have to figure out on which side of the boundary are my points. Are they on this side or are they on this side? On what side are my solutions? Okay, so what I'm going to do is, I'm always going to do this. I'm going to go to my y-intercept, which is at positive 2, and it tells me that y is less than or equal to. So I'm going to highlight my y-axis going down. Less than is going down. Y is less. So I'm going to go down, and every point below the boundary is a solution to my inequality. Okay, a good thing to do, because students struggle sometimes as to knowing which half plane to to shade in. A good thing to do is to check your solution, and what you can do to do that, it's very simple, is pick any point in your shaded half plane. And if 0, 0 happens to be in your shaded half plane, that's a really easy point to check. And what you do is you take 0, 0 and you put it back in to your inequality and you see if it makes a true statement. So let's do that. X is 0 plus 5 times 0, which is 0, is less than or equal to 10. Is it true that 0 is less than or equal to 10? Yes, that's true. So any point in the half plane that you've shaded that you plug into your original inequality should give you a true statement. Okay? All right, so, okay, number 3. Number 3 is another one that I'm going to do with you. Copy this down. 2x plus 3y is less than 6. All right, so again, my first step is to get this thing into slope-intercept form. Let's do that. Subtract 2x from both sides. 3y is less than negative 2x plus 6. Divide everybody by positive 3, because I'm dividing by a positive. I don't worry about flipping the inequality. So y is less than negative 2/3 x plus 2. So my slope in this case is negative 2/3. And again, my y-intercept is positive 2. All right? Now let's graph it. That's your y-axis. Here's your x-axis. Please draw your coordinate plane inside a square. Okay, I will draw the boundary in red. So my y-intercept is at positive 2. It's at positive 2. My slope is negative 2/3. So let me draw a few points. Down 2 to the right 3. Down 2 to the right 3. Down 2 to the right 3. And I'll do it a few times. I want to go all the way across that square. Up to the left 3. And I'll do that a few times. Okay. Now take a look at my inequality. Y is less than, not equal to. So in this case, my line is not going to be a solid line. I'm going to draw a broken dashed line. Okay? Like that. To show my boundary. Okay? So now the question is, which side am I going to shade? Which side of that boundary includes all of my solutions? Well, I look at my inequality. It says where y is less. Go to my y-intercept. Y is less goes down. So I will shade everything below the boundary, where y is below the boundary. Okay? This is your solution. And of course, whoops, sorry about that. And of course, your solution extends, but we're just going to show this small square, which is a piece of the true solution. Okay? All right, so let's go ahead and check if this is the right side, if we shaded the right side of the boundary. So again, we look to see that we can check with any point, but if 0, 0 happens to be shaded, that's an easy point to check. Okay, so it is. notice that 0, 0, the origin of our graph, is in the shaded half plane, so we'll use it, 0, 0. And we take that and we substitute it for x and y in our original inequality. So 2 times 0 plus 3 times 0 is less than 6. 2 times 0 is 0 plus 0 is 0. Is 0 less than 6? The answer is yes. Okay, so you can always check that you've shaded the right half plane, the correct half plane. Okay, all right. I want you to try number 4 on your own. Okay, so don't forget, you want to get this in an easy form to graph. You're going to graph it, and then you're going to see what kind of boundary you have, whether it's a solid line or a dashed line. Then you're going to shade the appropriate half plane. All right, go ahead and work on this on your own. Come on back and check your answer when you're done. Okay, take a look. This is one of those easy equations to graph, or boundaries to graph, because it's a vertical line at x is greater than or equal to negative 11. So look at my red boundary. That is the boundary of my inequality. It's going to be solid because my inequality includes the equal to sign. So it is part of the solution. So it's not dashed, but it is solid. And then everything that x is greater goes to the right of that boundary. So we're going to shade everything to the right. Okay. All right. Number 5. Let's do this one together. 4y minus 8 is greater than 12. So I notice right away this one does not have an x. So I know that if it only has a y, it's going to be a very simple horizontal line. So let's solve. Ready? Let's add 8 on both sides. 4y is greater than 20. We'll divide by 4 on both sides, and we see that y is greater than 5. Y is greater than 5. So let's graph that inequality. Okay, I'm going to put my x-axis way down here because I know that I have nothing on the negative side of the y-axis. Okay, so let's box it in. Always remember, please, when you're graphing inequalities, to draw them within a box. Okay, I'm going to draw my boundary, and I ask myself, is my boundary a solid line or is it a dashed line? And I know it's going to be a dashed line because it's a greater than, not a greater than or equal to. Okay, so there is my boundary. It's at y is 5. And then which way am I going to shade? Well, wherever y is greater, so it's going to be above the boundary. The y's get greater as you move up on the y-axis. And so that would be the graph of the inequality. Okay. All right, a little independent practice, please. You will do number 5. Number 7, number 9, 5, 7, 9, and that's it. That's it. 5, 7, and 9. Whoops. 5, 7, and 9 is all you're doing on this one. Okay? All right, so jot down any questions. We will practice this tomorrow, and then we will continue working on graphing inequalities. God bless you. Have a great night.